Okay, mates, Egor's Garage here. We're going to call this episode To Battery or Not to Battery. That is the question. All right. I'm going to do my best to explain this. For whatever reason, Honda chose to do a battery ignition on all these engines, the 90cc Cub, or the trail versions, or any of the what I would call the big block engines. But there is one pushrod 50 engine called the C102. It has an electric starter. It has a battery ignition. All of the early step-through Cubs were magnetos. I don't understand when you're taking something out into the bush why you would have somewhat of a failure situation if the battery was dead. But anyhow, my friend in England was trying to run his CT90 big block with no battery. He was getting a few sparks once in a while. I'll explain why. You can see in the rotor, these are permanent magnets. These things are, they'll pick up the tails pretty strong. You can see the segments of the magnets, right? Here is the generator coil. This one's been modified. Somebody was trying to turn this into a 12-volt generator. I don't know if they were successful. I've never tried it. I just inherited it somehow. I don't even know where. Anyhow, you can see that each coil has its own position. As these magnets go through and cut the magnetic field cuts the lines of force through these windings, it induces current. Okay, so as the engine rotates, each time the magnet cuts these coils, it induces a voltage. Okay, these are 6 volt. Here's an example of what it looks like. If you could see it on a oscilloscope, you would see that you would have a plus, say around, I think it's 7.9, but 8 volts, plus, then you go to 0 voltage on this line here, then it goes to a minus 8 volts. Each time this rotor goes through these phases of magnets, that's what it's doing, creating alternating current. Okay? Now, the way you charge a battery with alternating current, because it's a DC, it will only take a push charge. It has to be always, if it's alternating, like in the diagram, then it just goes, the current's going back and forth and never moves forward to push current into the battery. So what you end up having to do, and there's different ways of doing it, and this is one of them. This is the one that Honda used for years. This is called a Selenium Rectifier. What this is an electronic gate. What happens is, as the current comes in through whichever the corresponding wires are, it allows the current to go through and into the red and white wire, which is the one that's hooked to the battery. It allows the current to come off of this alternator and go through this electric gate and come out in this red and white wire, and it pushes the current into the battery essentially. The wires, this yellow wire, the white wire, come off of that alternator. The green wire is a ground, and yeah, that's it on here. Okay? And I'll explain why you have this white and this yellow wire also. But that's essentially what this thing's job is. This is the one for the little Honda Cub, as an example, that runs on a magneto. All it needed was enough to charge its little bitty battery so that it would run the tail light and the indicators and the speedo and things like that. So it's very light duty. It only has one winding inside of the flywheel, just as an example. Okay, the reason that Mateo's bike across the pond would run is because as he kicked the bike over, and it doesn't matter if the points are up in the top where the camshaft is. This is a pushrod motor. If the points open when those magnets are cutting through the coils, it induces a current. And there's a chance there's enough there to activate the coil and fire the spark plug. But what happens is, what is the kind of the bug in it is that this is an advanced mechanism. So as it's idling, the ignition's retarded, and then as the engine speeds up, these weights move out and go to an advanced ignition position, and increases the engine's ability to make power out of the energy, the fuel that's going in. Sooner and sooner the spark occurs. But what happens is when you kick these over, especially when you get one that's sloppy and old like this, it's supposed to be kind of firm, this is moving around and causing his ignition to go in and out of what you call phase. So if the points opened when it was cutting the coils, you get a spark. If this moves in, it's like just like this one's in very poor condition. It needs the springs tightened up. You can pinch these down and snug them up. Then, when the points open, at the right moments, of course, you get the proper ignition to the engine. You want to advance it more and more the faster the engine goes. Okay? I think that's about all we... Oh, the other second part of it is the extra windings. This doesn't have the key on it, but if the key was here, you'd notice that there's two positions. One of them is for driving in the daytime, and the other is for night. What Honda did, since this is a simple charging system, rather than having any kind of a regulator that regulates the current that's coming out of this fixed generator, what they did is there's two sets of windings in here. And so there's more windings in what you would call the night coils than there are in the day coils. And they're wound on top of each other. So what happens is when you turn the key to the night position, you add another set of windings to the charging system. And that ups the voltage to drive the current into the battery. Okay, there's different ways to do it. This bike is an early one, but you have the handlebar switch where you have the off position, then you have the high and low position. If you looked at the wires traveling through the bars, you would see that there's wires that basically connect that second set of windings to your battery that goes in the box on the other side. Okay? That's why you don't want to run too long with a burned out headlight in the headlight position, which this bike doesn't have, because you're pushing more current into the battery and it will literally boil the electrolyte out of the battery. This one hasn't been filled yet. So what we used to do in the old days is we used to put a switch in the headlight where we could turn the lamp off and we'd up the voltage and we could charge a battery that was somewhat dead. This system's not made to charge batteries, it's only to maintain the current. So as you're using your bike with a good battery and constantly everything's fine, the bike's sitting for a while, the battery goes down, it really needs to be brought up with a small battery charger, something that won't boil the battery, and then ridden and it will maintain. It's not really made to charge a battery. But like I said, what we used to do is sneak a switch in the headlight where we could flip the switch, leave it in the high headlight position, turn that off, and that would put more current and we could actually charge the battery. Don't advise it, but you can do what you want. So that's how they did it until you get to the very late models of these big block bikes, and then they actually have a tiny voltage regulator. And they use Zener diodes instead of these Selenium rectifiers to rectify and use it as a gate for the current flow. Anyhow, I hope this explains. If you need any more information, let me know. We'll see what we can do. Anyhow, the super magnets that are in these rotors is amazing all these years later. Anyhow, enough of this. All have fun. Bye for now.